Hello and welcome to the Target 38 video for AP Calculus. Target 38, I can use the net change theorem. This theorem, not a difficult one. If you can manage the setup, you should be all right. Why? The integral is a tool that can be used to calculate net change and total accumulation. That's a lot of mumbo jumbo. Basically, the integral calculates change. It is all the rectangles added up, and you can calculate the change in the rectangles up to a certain point, and the accumulated change. So we go back to the fundamental theorem of calculus. A function is continuous on the closed interval, and f is an antiderivative of f on the interval from a to b, then the integral of the function equals the antiderivative evaluated at the upper limit minus the antiderivative evaluated at the lower limit. Since f is an antiderivative of little f on the interval, another way to write the fundamental theorem is antiderivative of f prime of x dx from a to b equals f of b minus f of a. Well, what does f of b minus f of a give you? What is another meaning for f of b minus f of a? Well, it's the change in the two values. When you integrate, you find the net change. You go back to here, you integrate the derivative, you find the net change in the function. Well, I like to say it with a little rhyme. Integrate the rate, and that'll find the change. I know change doesn't rhyme, but great and rate do. So integrate the rate to find the net change. So here's an example. For these problems, a lot of times you're just going to want to show setup and answer. Sometimes, yeah, you're going to want to do it on a calculator because it's not a tough integral, but a lot of times it shows setup and answer. So a chemical flows into a storage tank at a rate of 180 plus 3t liters per minute, where 0 is less than or equal to t is less than or equal to 60. Find the amount of chemical that flows into the tank during the first 20 minutes. So we want an amount, and we're given the rate. If you have a rate and you want to find amount, integrate the rate. So integrate the rate. Respect to t, and it says for the first 20 minutes, so we'll go from 0 to 20. All right, and then we'll integrate the rate, shows setup and answer. This one you probably don't need to plug it in the calculator, so let's do this one by hand. This will be 180t plus 3 halves t squared from 0 to 20. So we got 180 times 20, that's 3,600, plus 20 squared is 400, over 2 is 3 times 200. So that's 3,600 plus 600, that's 4,200 liters. So 3,200 liters flow into the tank during the first 20 minutes. All right, try this one. Pause it, try it, and we'll work it out. This one, since it's cube, maybe this one's a good one for a setup. Show setup and show answer. A particle is moving along a line so that its velocity is v of t equals t cubed minus 10t squared plus 29t minus 20 feet per second at time t. What is the displacement of the particle on the interval 1 to 5? All right, so we want to find displacement, which is change in position. So to find change in position, we integrate the rate, which is the velocity. So we'll integrate velocity with respect to time from 1 to 5, and that'll give us our change in position. All right, right, this one will show setup and answer. Our function was t cubed minus 10t squared plus 29t minus 20. That is my velocity function. And then we'll integrate that from 1 to 5. Integrate the velocity with respect to time. And we see it's 32 seconds. Or 32 thirds. Sorry, 32 thirds. You guys can probably say, what do you think in 32 seconds? So the displacement is 32 thirds. If you want to do a decimal, fine. Some of your calculators probably gave you a decimal. That's great. Otherwise, this is an acceptable answer. Maybe you don't need all the parentheses, but you get the idea. All right, try this one. Pause it, work through it. Water flow. Water flows from a storage tank at a rate of 500 minus 5t liters per minute. Find the amount of water that flows out of the tank during the first 18 minutes. Here's our rate, and we want to find an amount. To find an amount, integrate the rate. So integrate from 0 to 18, 500 minus 5t with respect to t. All right, so we'll integrate from 0 to 18, 500 minus 5t with respect to t. So we get 8,190 is our answer. And that is in liters. All right, so 8,190 liters flow into the tank during the first 18 minutes. All right, pause this one and give it a try and hit play once you've given it a try. Oil leak at 1 o'clock. Oil begins leaking from a tank at a rate of 4 plus 0.75 t gallons per hour. How much oil is lost from 1 o'clock to 4 o'clock? How much oil is lost from 4 o'clock to 7 o'clock? Compare your answers from part A and B. What do you notice? All right, so we'll do part A first. Part A, in purple, we're losing oil at a rate of 4 plus 0.75 t with respect to t from 1 o'clock to 4 o'clock. And it begins at 1 o'clock. So this is t equals 0 when it's 1 o'clock. And t equals 3 at 4 o'clock. And t equals 6 at 7 o'clock. So for part A, we'll do from 0 to 3. Okay, so integrate. Integrate from 0 to 3. 4 plus 0.75 t with respect to t. So from 0 to 3, we lose, or I suppose I should read the question a little closer. We lose 15.375 gallons of oil. And then we'll do part B. Part B is the same thing, except we're not doing from 0 to 3. We're doing from 3 to 6. So we'll change our function to be from 3 to 6, and not from 0 to 3. Or from 0 to 6, I think I might have said. 22.125. So 22.125 gallons of oil. All right, so what do you notice? You notice that the oil's leaking faster. Because from 0 to 3, you lost 15 gallons. From 3 to 6, you lost more. Should be a no-brainer because the rate right here has a positive slope. So you're going to lose more as time goes on. So we lost more oil in the last 3 hours than in the first 3 hours. All right. So in conclusion, the net change theorem. If you're given a rate, you can find the net change by integrating the rate. Integrate the rate. And that will equal your net change. Here I gave you a concrete example of velocity and position, but it works for any time you have a rate. All right, make sure you're working the daily quizzes. I noticed a lot of you didn't do it last night. I'll give you one more night on this, but there will be a new one tomorrow.